everyone, welcome. As you can read on the screen, 5 reasons why you should use Golang. So I'm going to be introducing you to Andrew and Joe, who will be taking through more of this. I work in the BJSS Academy, a little bit more about that right at the end. But without further ado, I think we should hand over to Andrew and Joe. Tell us more about the top 5 reasons. The top 5 or just any 5?
Just 5 reasons.
Just
I think.
5 reasons. Yeah. Just 5 reasons. There are more than 5, so these aren't even the top 5, but 5 reasons why you should use Golang. So, Andrew, Joe, over to you.
Yeah, I'll just go to the next slide.
All right. Good morning. I'm Joseph. I've been with BJSS, a software engineer, for about coming up on 2.5 years. Originally, I was a placement student at the Leeds office, at the head office, and now I'm at Manchester. And I'm on the Vet 365 project as part of the responsible gambling team.
Yep. And good afternoon, everyone. I'm Andrew Beattie. I'm a software engineer for about 4 years. I've been with BJSS just coming up to 2 now. I was a previous graduate for Santander Technology, and I'm also at the Bet 365 contract working within the payments team. So I'll go a little bit into a brief history of Go just to begin with. So Go is a kind of a new language. If you don't know anything about it, kind of came around in 2009. And these 3 people that you can see here, Ken Thompson, Robert Grezimir, and Rob Pike, were kind of the main innovators behind the language. They were all engineers at Google at the time. And a little bit out of context, but a snippet from an interview with Ken, which was when they started, it was kind of a pure research project, and they kind of got together and decided that they hated C++. Now, maybe that's not the only case, but essentially they were looking for a language that was it'd be easy to use, but still kind of tackle the problems and challenges that we were facing at Google at the time. And they were kind of looking at it as more of a way to have a language that was more productive and scalable, for better terms of words. So without further ado, we're not going down a deep history into Go, but I'll just hand over to Joe to give you one of the first reasons why we think you should be using it.
All right, so our first reason is it's fast, and it's fast in a few ways. First off, to learn. The code, we found ourselves writing pretty simple code on Bet 365. It's not kind of like hidden behind millions of design patterns, as Java can often end up as. So it's more or less what you read is what it is. There's no hidden flow control. So if you've done C++ before, you'll know there's things like a copy constructor where magic can happen in the background that isn't obvious from the code. And there's no function overloading. The function only exists with one name, and it just makes it so it's obvious immediately what that code is. And next, we've got the Go Playground. So it's an online editor where you can run your code, and you can even embed it into websites. So you'll find lots of interactive learning tools that will use the Go Playground. Next, we have to compile. The language runs really fast in compilation. I built one of my APIs on project the other day, and it took like 0.3 seconds to do a release build. If you ever use, again, my background is Java previously. If you use like Gradle or Maven, then you'll know that they're a bit slower to use. But I'll say that the turnaround in Go is just instantaneous, and you have your working binary. And next we have it's compiled strongly typed and statically. So it's kind of in the same vein of performance as Java and C#.
Cool. So I'll go into the second point. So Golang is also lightweight in terms of it being a minimal syntax and few reserved keywords. So as Joe mentioned, it's quite fast to learn the language and pick it up. So a few hours to kind of get a handle on the syntax is normally common, and generally the standard library isn't too bloated. Being a young language as it is now, I'm sure there might be bloat down the line, but currently it's quite lightweight. In terms of the few reserved keywords in comparison to like C# and Java, which is C#'s 102 reserved keywords, Java's 50. Go only currently has 25 reserved keywords. So even just in small things like that, you can see that it tries to push simplicity as its main key feature. In terms of setup, download, and installation, and the setups instructions for Golang are actually very simple. You can see here that it's only about 4 commands, and even if you're wanting to upgrade, you only need to use the first one, which would just be to remove the existing Go install and just replace it with the updated version, not messing around with your path. In terms of it being garbage collected, there's no memory management that you have to do up front, which you might have seen with like C. But this kind of brings into inherence to the asynchronous model that it runs. So with regards to Go, the runtime scheduler manages what we'd consider to be green threads, or maybe like an abstraction. Go's thread stack size is quite small in comparison to these. So the runtime scheduler has got quite a few optimizations that means that the compiling is quite fast. So for instance, it's not uncommon within a Go program to have hundreds of thousands of green threads, or what they're called in Go as Go routines. And that's to kind of show that they are really pushing how they optimize the runtime scheduler and management of memory. So breaking this down into a little bit and showing you an example. So here we have a HTTP server example. Not going too deep into it, but what this program is doing essentially is it's taking a request in as an input string, and you're telling it how many times to repeat that string. On the outside of that, you will get the string repeated as well as a request count. So going from top to bottom on the left to right, you can see here we've got our imports. We then have our main entry function where we're setting up the handler for the HTTP server. You would have your 2 request structs, which obviously have your JSON tags on here. And then onto the right image, we've got a scoped variable, which is a request count, and then our actual handler server. So as you can see, it kind of goes down into checking if the method is available. So we're just checking if there's a post, otherwise we'll return out. We then decode our request structure using the JSON encoder, which is built into the library. Then we will do our repeat and obviously set out our response structure to be written back on the encoder at the final part. Now, this is kind of just showing that the HTTP package being built in to Go is it's something that you consider maybe in other languages that might take you a while to set up, but really from the install to getting a file like this in Go, it can take probably within an hour or 2, which is quite impressive considering if you just want to whip up a quick prototype. One thing I will point out here, if you notice the request back out, which is using atomics. Now, atomics are one method of handling concurrency in Go. So for instance, when we have this handler set up, you might have hundreds of requests coming into the handler. And obviously we're then needing to be thread safe and concurrency safe. So what atomics is doing is essentially incrementing the counter by 1. But when we consider when we're incrementing a scoped variable, there's 3 steps in this process. So you need to load that request count. We then need to increment it and store it. So if 2 requests were to come in at the same time, you might end up with a stale value, and both would register as being the first request count when actually there was one done at the same time. So by using this atomics, we can safely execute the increment. But in terms of concurrency, I'll pass over to Joe for the next step on what Go uses concurrency for and the importance of it.
Yeah, so the whole point of Go pretty much is concurrency. It's baked in as a first-class feature, and that is in the form of the Go keyword. So any function you can call it asynchronously in a new Go routine just by putting the word Go in front of where you call it. So it's not like other languages where you have async functions or sync functions. Everything can be called either way, which is really cool. There's an article about this, which refers to async and non-async functions and red and blue functions. It's worth a read at some point if you have the time. So when you have concurrent processes, you need to have no race conditions in how you share your memory. And the main method of that is something called a channel. And I think the best way to think about this is if you imagine a relay race, the baton is kind of like the channel. So once you've passed over the baton, the next channel, the next go routine, which received over the channel, can start going. So in this little example, we have our function main, where we send requests to 3 different URLs, and then we have something called a select. And a select allows us to pull from multiple different channels, and whichever one returns first will be the path that we take. So it's kind of like a switch in a way. Then you'll see in our send request function, we give it a URL of a string and we return a channel of a string. So the channel can pass a string over it, as in like the relay baton. You'll see here we have gofunc, which is an anonymous function being called in its own Go routine, where we request the URL, we then read the body, and then we send the string of the contents over the channel. And this code, thankfully, the BJSS website returns first. It's looking good for us.
Cool. So a little bit away from that and going into a little bit of the tooling as well. So what I would say is quite useful, and especially as a developer using Go, is that Go is essentially a batteries included language, I would say. So with regards to testing, it's got its own testing framework built in, and that's via the keyword Go test. So just breaking this down, you can see here, I mean, essentially we wouldn't want to deploy this to production, but we've got a lot of failing tests, okay? So Go's quick feedback loop, as you can see, is that you can run Go test, and these tests executed within a couple of seconds, if that. But it's also quite flexible in many ways. There's the options to do sub-testing. So if you look into the third test that's failing, we've got this test handle get, and it's actually running 2 tests here, because you can kind of set it up as a table-driven test or sub-test as well. So we're passing in different parameters into the test and expecting our different return codes. This obviously is quite useful in how it can be flexible, but then further to that, you've got these race flags that you can pass into testing. So breaking that a little bit, there's also an extension of Go test, which is called bench or benchmarking. So with benchmarking, what we're essentially doing is starting to plan for optimization of our code and performance testing of our code. And this is obviously a native feature for Golang as well in terms of its testing framework. So we can start actually running parallel tests with bench and Go test and sub-testing, and we can start actually trying to detect if our application is going to be thread safe. Now, just from going through that, you can see that the testing framework, even though it can be quite simple, it can start building up and being quite complex in terms of the testing conditions that you're wanting to do. So for instance, by using sub-testing, we can have like common setup data, or setting up common data for these tests. And then even further, obviously, we've got parallel testing, which can start to get quite heavy in terms of how we're going to look at this. But bench will relate into Joe's next one as well in terms of how we start looking at optimization and performance testing. Goes further tooling, it has a doc functionality, and this is obviously driven by commenting code, which I think quite a few languages do have, but it's useful to know that it's got it built in. It also has a couple of other features such as vet. So Go vetting is essentially running standard rules for your code to check if it's not doing anything funky or it's going to have any issues. And further to that, it's got a Go thumped, and this tool actually is going to be formatting it. So it's good in terms of when you're working across projects to try and keep consistency in how your code is laid out, and it's already built into the language. Finally, we've got Go mod, and this can be used in tandem with another command called Go get, and that's essentially starting to look at how we use dependency management within our Go services. So I would consider this similar to maybe what you would be used in NPM package management in JavaScript, but we can start looking at how we're dealing with its sub-dependencies of a service and updating these to keep consistent across all of them. So pushing on to Joe, he'll kind of break down a little bit more about bench and then into profiling.
All right, so PPROF is used for performance profiling, which is very important when you're trying to work out whether your code can do what it needs to do and whether it can do it better. And it's very easy to spin up on your Go services. You simply need to import net HTTP PPROF, and you start the default HTTP server in a Go routine using the Go keyword. And then you can see on the right-hand side, it opens on the port, and it will show you a load of stats about your current running Go program. In this case, I had 1,812 Go routines running when I took the screenshot. If you click on where it says Go routine, you can then see exactly where all of the Go routines in the program are currently waiting for. So you'll see I have 998 Go routines on line 88 of topic manager.go, presumably waiting for a value to be passed over a channel. So this is incredibly useful for when you're writing some highly concurrent code and you've got some kind of deadlock resulting in some bad state in your program. You can tell exactly where things are going wrong. Expanding on this, we can then use the PPROF tool in Go to take a performance profile of our code. And periodically, it polls your program to see where everything is at the current point. So you get this nice little chart showing what's calling what and how much time is being spent in each place. And then you can get it in a flame chart form. So this is really useful for like an overall breakdown of your program's runtime. You'll see there's this big light yellow section, which is about half the way across the net.write. And in this program, it was a pub sub server, and it was the writing out of thousands of individual messages, which results in a lot of syscalls, which are relatively slow to do. So I decided to optimize this by writing to a buffer, and then periodically I'd write the buffer out all at once. So I could write 1,000 messages at once. And you can see that the yellow section has become absolutely tiny. It's like a little bar about 80% of the way across. So you can get very nice charts showing you how you've improved your code's performance. Yeah, PPROF has been really powerful, and I've enjoyed using it when working with Go.
So now I appreciate that was maybe a quick stop tour of Go. It's a little bit of a history why we like using it, and there's probably a lot more to delve into as you start picking up the language. But we kind of reviewed through the fast elements of Go, let alone just kind of learning it. Obviously, our experiences of learning it have been varied, but I guess Dan can talk about the academy as well. It is a lightweight language, but I think one of the most powerful things in Go is obviously the ease of concurrency and it being a native feature in the language compared to other languages. But then coming forth into the tooling and profiling as developers on the day-to-day, when we're starting to deal with concurrency and large throughput systems, we need to ensure that our systems are safe for production. And that's where the tooling and profiling built in has actually been probably one of the most outstanding parts of using Go, ensuring that we can essentially monitor, debug, and fix our programs when required. So that's pretty much it from us. I'll just pass over to Dan, I think, because he's going to just kind of cover a final slide on the academy.
Indeed, yes. Quite often we get asked, well, where do I start? And what I've done is I've collated a few different resources that people have used and recommended from various people working on various different accounts. There's Learn Go with tests. Now I really like this because it gets you up very quickly and uses that built-in test framework with Go, which is fantastic. Of course, there's the official site. Now this is where the playground lives that you will have seen. That allows you in the browser to actually run Go code. They've got loads and loads of resources there at go.dev. And something we have used recently, just internally trialing out, was Todd McLeod's Go course. Now, if you're a particular fan of a style where a very laconic laconic American speaks to you in a very chummy fashion, this is probably the course for you. This is a really good resource. They all teach you more or less the same things. Now, getting up with the syntax is fairly straightforward, fairly quick. It's then the more complex things. So go and try out various challenges, start building HTTP servers, start looking at TCP, and especially the concurrency, it can get really tricky really quickly. So it's quick to learn the syntax, and I think it probably takes a bit longer to learn all the nuances, and you won't necessarily learn that in a course. That's sort of the thing you learn by doing, by experience. So recently at the Academy, in the Engineering Academy, we've taken on responsibility for our Go training. So those people who've had experience maybe with Python, with C#, with Java, and teaching them Go. Now, part of it is a mindset. So we're talking about functional programming, not necessarily OO, although don't get me wrong, Go does OO extremely well. But there are nuances in there. There are things like interfaces, but that's not a classic Java interface. So it takes a little bit of time for people just to get that right in their head. But we do that over a series of weeks. We do instructor-led training. Then we go on to building more projects, again, around those HTTP, TCP things, working with concurrency, and then breaking it, because that's what makes everyone sad. But it's okay, you had loads of tests, I promise you'll be safe. And then we go into much more of that project stuff, and then we put people onto projects like Bet365, where they can learn more. So those are some resources to start with. You can always come and have a chat with BJSS if you'd like to learn more about Go. But then I believe there's a final slide, which is a very exciting one, which asks if there are any questions from the audience. So Fern chimes up.
Hey everyone. If you do have any questions, it's super easy to write them in the Q&A box. So you just need to press the Q&A button at the bottom and write it in the pop-up. I see we have a question that's come in already. So hi, I think defer, oh, this is going to be
defer responsive body.close was missing on the Go concurrency slide 3 of 5. That's what I love.
Do we have an answer to that, Andrew?
Well, we could go back and have a look, couldn't we? We could see if it's
let's debug it.
Debug it. Put it in the Go playground. Share it.
Yeah. Ideally, you probably would want that in. You're right. It's just like a little code example to show what's going on.
Thanks for pointing out.
Sorry, you're one slide too early.
Oh, to this one.
It was this one, yes.
Yeah.
Yeah, I mean, the main point of this one was like the whole concurrency feature rather than the closing the body. But yes.
That's not safe Go code, Joe. That's fine.
Yeah, this will never make it into production.
Yeah.
I suppose the question from me is, what is your favorite thing about Go? Joe, do you want to answer that one?
Yeah, so I as I say, like with the whole lightweight point, I find it incredibly easy to things I normally use Python for just to pick up can easily be done in Go as well. You can just spin up a file super easily, just try something out, and it's very easy just to run like multiple servers from one program. The Go keyword just makes the whole concurrency very easy to handle in my experience.
We have another question that's come in as well. Thanks both, definitely a good intro to the language. If I remember correctly, Go uses pointers. How do you find those coming from a language that doesn't use pointers? P.S. It's good to see you again, Andrew, smiley face.
Yeah. Coming from a language that doesn't use pointers, I think it can be a little bit of a pitfall. And to be honest, we've seen some issues with production code because people need to start figuring out how to use pointers. But I think when you start coming into this and start realizing how referencing and pointers work with Go, it can be quite useful for kind of jumping between passing by reference and actually passing by value. I don't really know what else to really drive on that. Joe, have you got any kind of thoughts on it coming from Java?
Yeah, I mean, passing by value is nice sometimes, but of course, a pointer is good for not doing copies everywhere. But it really depends on the struct, really. If you're doing massive structs, maybe you don't want to copy them. Yeah, I mean, I've not had pointer issues, especially when you use an interface anyway. It becomes a pointer hidden away. So yeah, just play around a bit, get used to them. Works out okay.
Thanks, guys. I might need assistance with this one as well, Dan. How big is the Go dev community compared to Java? And then is that
C#.
C#?
Yep.
Cool, etc. Thank you.
There's an interesting thing. So I was reading this earlier. Is the large majority, over 85% of people using Go, have had 3 or more years experience in programming. So I don't think it's necessarily young enough coming and being picked up by the youngsters, but it is growing. So they had, I think it was 10,000 responses to their 2020 survey, and that was just from the Go dev community, around what they were using it, the size of company, that sort of thing. So I think it's growing. I wouldn't say it's as big as the Java one, but we'll see, I guess.
I think one of the interesting things I'd add on that is that if you come across quite early on in the community, they've specified like the Slack community. So they've even got like this own kind of open source Slack community for Go that's quite useful to jump into. And being an open source project as well, there's always people jumping around, and I think it's only going to grow, to be honest, given the language uptake. Yeah.
I think there was another bit on it. Was actually half of the respondents had only been using Go less than 2 years, so that actually points to a big uptick over the last couple of years. I do like the next one though from Adam, which, other than only knowing Java or C#, why would you not choose Go? So this is a turn the thing on the head. Why wouldn't you choose Go?
If you need generic data structures, because there's no generics just yet, but there will be next year. Like you'll find yourself sometimes writing like a contains function to check if you have like a value in a slice being the equivalent of a list in Go. No generics is slightly annoying every now and then, but as I say, it's coming, and it's not been a super big issue for our workload in particular.
Yeah, I think I'd say onto that is that it depends on why you choose any language for a project or a service. Obviously, if you start thinking that this service is going to need quite concurrency-based programming, or it's dealing with a lot of large data structures that are going around, so then you could maybe say, okay, that's probably a good use case for writing the service in Go. But generally, I'd say it's just down to the team and obviously the company sometimes to say, well, we're going to be a Java team and that's it. But there's a lot of benefits, I think, in not saying that it's just choose one over the other. It's choosing one for the right job as well.
Do you think Go could replace Java as a back-end technology? So
I was laughing at the sixth reason. In terms of could Go replace Java as a backend, yeah, I mean that's basically what we're doing on Bet365, writing lots of like backend HTTP services. I think in particular it shines on smaller APIs. So as we're going to like kind of like a more microservice world, it's like Go is just very nice to use for that. Oh, sixth reason, Andrew.
I don't know if I have a sixth reason.
They got a cool mascot.
Yeah, they do have a cool mascot. Yeah.
Love that answer. What's his name again?
I don't know the name, but he's a gopher.
Yeah.
Love it. Is Go only a back-end tech?
I think you can do WASM with it, but it's not a big thing as far as I know.
Yeah, you can do server-side rendering and pass out the templates, right?
Yeah, but yeah, it's not really front end, is it? I've not really looked into like doing Go WASM for using on the front end. I think it is a thing, but I couldn't say much about it. I don't think it's a big thing yet. User deployment. yeah, it has been easy to deploy, hasn't it? In your experience, Andrew?
Yeah, some of the trade-offs we're seeing is the footprint that it's leaving with some of the services as well. So in terms of deployment, it obviously brings into anything that other languages would do. So if you're going into any of your pipelines or your deployment infrastructures, it's probably the same, because most people end up these days are probably using Docker or some element of that as well. So yeah.
Oh yeah, and to add on to deployment, it compiles just to a binary, so you can like compile it on one machine and just move over that. You don't need a runtime. So like if you were like releasing a Java thing, you'd have to, yeah, it's just all nice and packaged together is what I'm trying to get at.
It compiles to a single binary file.
Yes, it does.
That was a quick answer. That was a good short and sweet, but all that was needed. Thank you everyone for your questions. We'll hang around for another minute or so in case anyone else has any questions. But yeah, thank you so much. It's been great to hear what your feedback has been and really see what you guys think. And thanks to our speakers as well for your time. It's really interesting to watch for me.